Welcome to This Explainer. Today, we're diving into a fascinating paper that basically flips everything we've been hearing about current AI right on its head. I mean, we've all seen the flashy headlines claiming AI is totally ready to take over the world, right? Well, this research pulls back the curtain in a really eye-opening way.
Right off the bat, we gotta ask a pretty surprising question. Are these massive AI models actually smart? Or are they just, really good at taking standardized tests? Think about how we measure everyday human intelligence versus how we test a computer. It's a really critical distinction, and it completely sets the stage for what we're going to explore today. So, let's unpack this huge misconception. The media absolutely loves to hype up AI for passing the bar exam or crushing the medical licensing exams. But here's the wild part. These exact same top-tier models will often completely fail at tasks an average human could knock out in 10 minutes. We're talking about things as basic as looking through an Excel spreadsheet to find a specific sales number. Why is there such a massive gap? And that brings us to a seriously groundbreaking paper introducing GAIA. This research is a collaboration between teams at Meta and Hugging Face, and they essentially decided to build a benchmark that tests what AI can actually accomplish in the messy, unstructured real world, rather than in some sterile, perfectly controlled testing environment.
So, what exactly is Gaia? Well, if you think about current AI as this sort of textbook savant that's memorized the entire internet and can easily ace a multiple choice test, Gaia, which stands for General AI Assistance, tests whether that savant can actually do the job of a basic executive assistant. It forces the AI to use fundamental everyday abilities. We're talking reasoning, handling different media files, actual web browsing, and tool use to answer questions that are conceptually incredibly simple for a human. The AI evaluation problem. Before we look at the test itself, why do we even need a new benchmark in the first place? Well, the biggest issue is that current tests are incredibly gameable. We have these standard benchmarks, like the MMLU, which is this massive multiple choice test, but they get saturated super fast because they're stuck in closed environments. An AI can literally just guess the right answer without truly understanding the logical steps to get there. Plus, because these models ingest so much text during training, there's a massive risk of data contamination. The AI might just be regurgitating a memorized answer, instead of, actually thinking. Introducing the GAIA benchmark. This is where the researchers proposed a totally different approach. To actually solve a GAIA question, an AI has to mimic a real-world workflow, kind of like following a whiteboard lesson in logic. Step 1, it has to actively browse the real open internet or use a coding tool. Step 2, it has to process messy multimodal data, like reading a PDF or analyzing an image. And finally, step 3, it must output exactly one precise, verifiable, factual answer. No waffling, no long essays, just a specific number or a short string of text. If it hallucinates or makes even one tiny misstep, it entirely fails. Real-world AI testing. Let's see how this actually plays out across 3 distinct levels of difficulty. Let's look at a level 2 problem. Imagine giving an AI a picture of a generic ice cream pint's nutrition label. The AI is asked, if this whole pint is made up of ice cream, how many percent above or below the US federal standards for butterfat content is it, using the standards reported by Wikipedia in 2020? To get the exact answer, which is plus 4.6 by the way, the AI has to read the image, calculate the total fat per container, browse the web for that specific 2020 Wikipedia standard, and then do the math. A human can do this pretty easily, but for an AI, it requires a completely flawless sequence of distinct tool uses. Now, level 1 questions are a bit simpler. They basically require basic web browsing to find a specific fact, usually taking fewer than 5 steps and relying on just one tool. A good example would be looking up the actual enrollment count for a specific clinical trial from 2018 on the NIH website. The ground truth answer is exactly 90, so no complex math, just accurate navigation and data extraction. But level 3? These are incredibly complex for an AI, even though a human could probably knock it out in 15 or 20 minutes. One level 3 example gives the AI a NASA astronomy picture of the day from January 2006 showing 2 astronauts. The AI must identify the smaller astronaut, figure out which NASA astronaut group they belong to, find out who in that exact group spent the least time in space, and then output their last name and the precise minutes they spent in space. The correct answer is White 5876. It requires arbitrarily long sequences of actions, multiple tools running at once, and absolutely no room for approximation.
Now, when you map out exactly what capabilities are required to solve these 466 GAIA questions, web browsing absolutely dominates. To solve these tasks, the AI completely depends on being able to seamlessly use tools like web browsers, coding interpreters, and diverse file readers. It simply cannot just rely on the text it memorized during its initial training. Humans versus advanced AI. Here is the million-dollar question. How did the AI actually do? The results are, frankly, staggering. When you test everyday, non-expert humans on these questions, they hit a 92% success rate. We're just naturally good at navigating our own digital world. But GPT-4, the most powerful model tested at the time, even when equipped with custom plugins, managed a dismal 15% overall success rate. And remember, the standard GPT-4 without plugins did even worse. And if we break that down even further, we see that even on the absolute easiest level 1 questions, AI assistants struggle immensely with diverse file reading and handling different forms of media. The AI peaks at barely a 30% success rate on level 1. And get this, that's only when human operators heavily intervene to manually select the perfect plugins for the AI to use. If it has to use an autonomous agent, like AutoGPT, which tries to automatically string together actions to select its own tools, it fails spectacularly. But here is the absolute kicker. 0%. That is the exact success rate of GPT-4 on the hardest level 3 questions. The AI that can pass the bar exam in the top 10% of humans cannot answer a single level 3 GAIA question correctly. Not one. The path to AGI. Why does this massive gap actually matter for our future? The researchers make a really profound point here. Passing a standardized law exam or writing a neat poem, that doesn't make an AI generally intelligent. True artificial general intelligence, or AGI, will only be achieved when a system can robustly navigate our messy, real-world tools exactly like we do. It needs to be able to click through a clunky website, open a PDF, realize it made a mistake, backtrack, and find the right answer. That adaptability is the hallmark of true intelligence. So, to wrap up our lesson today, number 1, real-world execution is just fundamentally harder for machines than standardized testing. Number 2, despite all the relentless hype, current top-tier AIs struggle heavily at basic human assistant tasks that require multi-step tool use. And number 3, solving this GAI benchmark without any human handholding is the actual next frontier. It's the next major milestone in AI research. Which really leaves us with this final thought to chew on. If the smartest AI in the world currently scores a literal 0% on finding and compiling basic information across the open web, how many years away are we really from true AGI? It definitely seems like the road ahead is a lot longer and a whole lot more complicated than the headlines would have you believe. Thanks for joining me on this explainer, and keep questioning the hype.